everyone, welcome. In this section, we'll be learning about increasing and decreasing functions and how to determine at what point or over which intervals the function is increasing and over which intervals the function is decreasing. So, let's first understand what is the meaning of an increasing function. It's fairly simple to understand. When the shape of a graph looks something like so. As you go towards the right, x values increase. So as x values increase, we expect y values to increase. That's called an increasing function. And when x values increase, all right, so let's write that in as an inequality. It's a number of inequalities. So at each, when you evaluate the function at those x values, you see this is a non-decreasing or rather an increasing red line there. Okay, so when the values of x increase in this on this blue curve here, as we go to the right, x values increase, then the function itself actually decreases. So you get that kind of a reverse inequality. Therefore, so you should remember that gradient of the curve will be positive whenever the function is increasing and the gradient will be negative when it's decreasing. What do we indicate the gradient with? We indicate the gradient with f dash. So therefore f dash of x will be positive when it's increasing, and notice I'm not using the equality sign, I'm saving that for another time. So here the blue line, the gradient will be negative, it will be below zero. So these are the inequalities you should get used to writing. So let's have a read of this section here. At this on this curve, let's say this is x square negative x square plus some constant because the intercept is positive, and I'm showing you this this line where you see a horizontal line here. This particular blue line is where the gradient is zero. Now this is the only there is a turning point here. Over here on the y-axis is a point called stationary point. Alright, if you haven't heard of this word before, that means when the gradient is zero, okay, f dash of x will be zero. Whatever x value we substitute into there, not necessarily because it's on the y-axis. It just happens to be that this function is negative x squared plus, let's say, 10. So the y value here is 10. So a stationary point is just telling us about the gradient of the function being zero. Now we're going to figure out later, we can figure out what values it will be zero. We will set the derivative function equal to zero and then we'll solve for it. For example, we could find what's the derivative function of this. It will be minus 2x, so f dash of x here is minus 2x, and the 10 disappears. And when you want to find the stationary point, you set the f dash equal to 0 and you solve for x. Solving for x, the only answers to this equation is x equals to 0. Therefore, that's why in this particular case the stationary point lies whenever x is 0. Now, you substitute 0 into the function, you say y value is 10. But, alright, the point of this is that the green line here has a positive gradient. Why? Because the function is increasing on the left side of the y-axis and the function is decreasing on the right side. Therefore, we wrote in there f dash of x is less than 0. So just make note of those inequalities. That's what we're gonna do. We're gonna be using those in the next example also. So in this example, we have been given a function which is a cubic function and we've been told is increasing. So show that, sorry, my bad, it says show that this function is increasing. So what we need to do is find the derivative and see what does the derivative look like. Finding the derivative after applying the power rule is 3x squared plus 24. Now, is there at any point any x value that can make this negative? So think about it. It's 3 times x squared. Whether you put a minus million inside that square bracket there, it will always be positive because we are even a minus 10 here will turn it into, but because of the square sign there, it will become positive. So that 3 is always multiplied by a positive value, and also we are all, so that's always above 0. That's my point there, and we are adding something that is still even make it even more positive. So that's why you write a little sentence for the examiner. You say x squared is always positive for all values of x, therefore this expression will always be positive. So it will be increasing. So therefore the gradient will always be positive, hence increasing function, an increasing function. Alright, so there you go. There is a graph for it as well. In this next example, in the first part, we've been asked to find the domain of values or x values that will be for this interval the function is decreasing, and find the interval where the function is increasing. So is this similar to the last problem? No. This is where you got x cubed here and minus 9x at the end. So when we differentiate this function, what do we get? The graph almost doesn't. This is just to say that yes, there is certain interval over which it will be decreasing, and there are two other separate intervals where it's increasing. So what do we get when we differentiate this function? We're going to get 3x squared plus 9, no, 6x minus 9. Alright, so what do we do with this derivative function? We are solving part A. So we say when it's decreasing, this derivative function must be 0. Going back to solving inequalities from chapter 3, and yeah, if you remember, to solve an inequality, first you factorize it and we try to find the roots. We can factor 3 out of everything and the function will be simplified to such. So we can find the factors of this, which is plus 3 and x minus 1, and that tells us the turning points are at x equals to minus 3, or notice I'm calling these roots uh, something else. So these are the roots of the equation. 3 we can discard there. So that's telling me that actually if this derivative function was 0, then these are actually called the turning points. Okay, so x will be a 1 and x will be minus 3. Okay, so that point, but we are not concerned with turning points in this uh, question. We are solving an inequality, so therefore we go ahead and check the value of x here is positive. So you think about this graph here is got roots that are at minus 3 and 1, and this inequality is talking about the y value here. So we're saying at what point this inequality, this expression for y is less than 0. So wherever x is between less than 1 and bigger than minus 3. So I'm gonna actually rub off this writing, and it's gonna be copied exactly as I've written it under this graph here. So actually when we yes, we went through exactly the same inequality and we found the roots, and now look, those those points where we found this is the inequality we solved, right? And we found this part of the graph where the gradient is negative is actually matches up with this graph. This is actually the this square uh, square x square graph is matching up with is one of this graph here. To solve it would have helped us to solve this inequality, but notice at a later stage in a different exercise, this is actually important uh, mm, important exercise where you actually sketch the gradient function. Might be the next exercise as well. So you actually need to understand to how to sketch the gradient function as well. The gradient function is this line here, okay? This function, we are sketching that as well. So when x is 0, the intercept is -9. So that's irrelevant. We've solved this interval x is between 1 and -3 for the decreasing part of the graph. So let's look at part B now. We are solving for increasing interval. We want to know for which x values this function will be increasing. So we take the same function, we are differentiating it, we're getting exactly the same output, but this time the important part is that this is the major difference. We're writing this inequality as the derivative being bigger than 0 because we want to look for increasing interval. Therefore, once we solve that inequality, the roots of it will be exactly same two roots, will be 1 and -3. So this time we are shading, notice we are shading here because we want the increasing part of the derivative function. So what values of x is it? X must be here, then x must be bigger than 1 and x must be less than -3. This is a disjoint set, so if you had to use your set notation, you would write it as something like x dot dot x -3 and use u because that's or means or. Okay, so that's just a review of set notation there for you. And we've set something extra which the question didn't ask. The stationary points are at x equals to -3. So notice these inequalities don't, at no point I'm saying it's equal to, and I'm not saying equal, I'm not putting equal sign anywhere because I'm saving it for stationary point. Some of the answers at the back of the book actually have inequalities with equal sign, but that's confusing to me and a lot of people. So I would write the answer as strict inequalities. Alright, so that's the last example and I'll see you in the next video.